Okay, now let's solve the problem 265. The mast is subjected to the three forces shown. Determine the coordinate direction angles alpha 1, beta 1, gamma 1 of F1 so that the resultant force acting on the mast is 0. So we are given three forces. Basically F1, which has a magnitude of 500 newtons. And then we have F2, which is 200 newtons, and F3, 300 newtons. F2 is in negative Z direction. So F3 is in negative Y direction. F1 has three components. It makes angle alpha 1 with x-axis, angle beta 1 with x, and angle gamma 1 with z-axis. So first thing that we need to do is we have to write the each force in Cartesian form, in Cartesian coordinates. Okay, so let's begin solving the problem, and let's write the problem. Now the magnitude of F1 is given. Let's write it. So F1 is equal to 500 newtons. F2 is equal to 200 newtons. And F3 is equal to 300 newtons. So these are the parameters that we have. Okay, now next thing is write each vector in Cartesian form. Let's begin from F1. Now if you look at the F1, as you see, F1 have all positive components in x, y, and z direction. Therefore, I can write it like this: F1 multiplied by cosine alpha 1 I vector plus F1 multiplied by cosine beta 1 j vector plus F1 multiplied by cosine gamma 1 k vector. Now let's write F2. Now if we look at the F2, we see that F2 is just lying on the z-axis and it has negative direction. So F2 is minus F2k. Now let's look at the F3. F3 is on negative y direction and it doesn't have any component on x and z axis. So it is minus F3 j vector. Okay. Now let's write the resultant force. resultant forces equal to F1 plus F2 plus F3. So let's write F1 first. F1 is equal to F1 cosine alpha 1 I vector plus F1 cosine beta 1 J vector plus cosine gamma 1 K vector plus I continue the expression in the next line, on the next line. So minus F2 K vector plus minus F3 J vector. Okay. Now I will sum up the components in each direction. So first I will begin with the x, the direction in the x. So I will sum up the coefficients of the I vectors first. So I only have the component of F1 cosine alpha 1 in the x direction. So this is F1 cosine alpha 1 I vector plus, now the j component, I have F1 cosine beta 1 and F3 here. So I don't have any j component coming from the F2. Therefore, this is F1 cosine beta 1 minus F3 j vector. Then the z component of the forces. Sorry, I forgot to write here F1. Huh? That has to be F1 plus F1 cosine gamma 1 minus F2 K vector. Now, basically, each of these components has to be equal to 0 in order the magnitude of the resultant force to be 0. From here, we can write like this. F1 cosine alpha 1 is equal to 0. Now, in order this expression to be 0, cosine alpha 1 has to be 0. This means that alpha 1 is equal to p divided by 2, or 90 degrees. So this is in radians. Okay, now from the y component of force has to be equal to 0 as well. This is just this expression. So F1 multiplied by cosine beta 1 minus F3 has to be equal to 0. From here, I can find the cosine beta 1. Cosine beta 1 is equal to F3 divided by F1. So F3 is 300, F1 is 500, which makes 0.8. From here, we can find the beta 1. Beta 1 is equal to 53.13 degrees. Now let's look at the z component. F1 cosine gamma 1 minus F2 is equal to 0. So cosine gamma 1 is equal to, let me write it below, a little bit below. Here, F1 cosine gamma 1 minus F2 is equal to 0. So this gives us cosine gamma 1 is equal to F2 divided by F1. So F2 is equal to 200, F1 is equal to 500, which gives me 0.4. From here, gamma 1 can be found as 66.42 degrees.